All right, we're going to look at factoring this polynomial. So this is similar to exam number 2, question 11. So you might have different numbers, but the idea is still the same. So it wants us to first factor the polynomial over the set of real numbers, and then we'll do it over the set of complex numbers. Okay, so first thing, when I look at this, I see 5 terms, and there's no way that I can see just to be able to group it. So I'm going to use that rational zeros theorem that says that possible zeros, rational ones, would be found by looking at the factors of the constant term, so in this case, the 12, over the factors of our lead coefficient, which is 1. So we have plus and minus 1, plus and minus 12, plus minus 2, plus minus 6, plus minus 3, plus minus 4. There's a ton. Separate those by commas so we can see those individual numbers. And then it's all over 1. Or negative 1, so really we're just getting all of those whole numbers. And so then the next thing that I'll want to do is use synthetic division to try and find some. So remember, this is kind of a guessing process. There's a few ways to minimize your guessing and narrow down those choices. So remember, you could have checked those out in the videos. But if I just start and say, okay, well, let's just try 1. Let's see what happens. I'm going to take the coefficients of my polynomial, and we'll see if 1 works. And again, our goal is to get a 0. So we'll see. Let's see. 4 times 4. Okay, that was wonderful. I got a 0. That was super lucky there. That doesn't always happen. All right. So then what happens with that, and again, that was just a total lucky guess that 1 is a 0. Then I know that it comes from a factor x minus 1. And because we're doing synthetic division, we know that the x minus 1 times the polynomial represented here. So remember, negative 12 starts with our constant term, and then we have 4x, and then we have 3x squared, and then it'll be 1x to the 3rd power. So we've kind of started factoring that f of x using that synthetic division to break apart our polynomial. So then sometimes we could do, or we have to do, synthetic division again on what's left over here to break that apart. But I see 4 terms, and it looks like we might be able to do some grouping. So I'm going to look at the first 2 terms, and they have an x squared in common. I'll factor that out. I'll be left with x minus 3. For the next 2, they have a 4 in common. I pulled that out, positive 4, and I'm left with x minus 3. And since these factors here are matching, we're going to pull that out, and then we'll be left with x squared plus 4. And I'm still going to have that x minus 1 here. So my entire f of x function can be written in that way. Now, x squared plus 4 is not a difference of 2 squares, so we cannot factor that over the real numbers. So, I mean, you can go a little bit further and say, okay, well, let's try and find the zeros. Again, that can't factor, but if I set x squared plus 4 equal to 0, I could minus 4, we're going to get x squared equals negative 4. Take the square root of both sides, and remember now, square root of negative 4, that's going to have an I come out, and so we're going to get plus and minus, we get those conjugates there, 2i. And so we have x equals plus or minus 2i. So it looks like if it was asking us to find our zeros, we would say x equals 1, 3, and then we have a positive 2i and a negative 2i. Now the question didn't ask us to find those, so that's just good kind of thinking. Yay, we were able to think about that. It wanted us to factor over the real numbers, and then it said to factor over the set of complex numbers. So the set of complex numbers means it wants us to have linear factors. That means no x squareds or anything like that. It's just to have a degree 1. And so you can see, because we have that 2i and negative 2i over the complex numbers, I'm going to kind of work backwards here. This will be x minus 1, x minus 3, and then x minus 2i for the 2i, and x plus 2i. So that's factored over the complex numbers. All those linear factors, just to power 1 on all of those x's. And so then if we're asked to factor over the real numbers, I can actually see that back here, where we had that x squared plus 4, because that got us those two imaginary solutions, 2i and negative 2i. So I know that that's like where I need to stop. I can't take x squared plus 4 and do more with it. Otherwise, I'm going to start getting those imaginary numbers, which leads us to that factoring over the complex numbers. So for the first question, over real numbers, it would be the x minus 1, x minus 3 times x squared plus 4. Over the complex numbers, it's saying go all the way, go to those linear factors, and that's when we define those two imaginary solutions. So hope that helps.